Ever wondered how to find sine and cosine when you only know the tangent value in the quadrant? Today, we're diving into a classic trigonometry problem, finding sine and cosine given that tangent of theta is 8/15 and theta is in the second quadrant. First, let's visualize tangent. Remember, tangent is simply the ratio of the opposite side to the adjacent side in a right triangle. So if tan theta is 8/15, we can imagine our opposite side as 8 units and our adjacent side as 15 units. Now, to find the hypotenuse, we use the Pythagorean theorem, a squared plus b squared equals c squared. Plugging in our values, 8 squared plus 15 squared gives us 64 plus 225, which equals 289. Taking the square root, our hypotenuse, r, is 17. So far, we have a triangle with sides 8, 15, and 17, but there's one crucial detail, the quadrant. Since theta is in the second quadrant, our x-coordinate must be negative, and our y-coordinate must be positive. This means our coordinates are -15, 8. Now we can find sine and cosine. Sine is y over r, so we have 8 over 17. And cosine is x over r, which gives us -15 over 17. Let's quickly verify this. If we plug these values into the Pythagorean identity, sine squared plus cosine squared, we get 8/17 squared plus -15/17 squared. This simplifies to 64 289ths plus 225 289ths, which indeed equals 289 289ths, or 1. It checks out. And there you have it. From a simple tangent ratio and a quadrant clue, we've successfully found both sine and cosine.